Today we're going to determine the empirical formula based on the information that we have about percent composition by mass. So, determining empirical formula from percent composition information by mass. Here's my given information. So given, what am I given? I'm given the percent composition by mass. So I have some sodium, some hydrogen, some carbon, and some oxygen. And what am I required to do? What am I trying to do? I'm trying to determine the empirical formula. How do I go about this? Well, if I knew how many moles I had, I could probably be able to find the empirical formula. So my first step is going to be that I assume I have a 100 gram sample. Why 100 grams? Why 100 gram sample? Because it's going to be easy to figure out how many grams of each of the component elements make up this compound. So in this sample, because it's 100 grams and 27.37% is sodium, then I will have 27.37 grams of sodium. The same goes for hydrogen. I'll have 1.200 grams of hydrogen, 14.30 grams of carbon, and 57.14 grams of oxygen. So now that I know how many grams I have, I can find how many moles I have. So step 2, determine how many moles of each element I have. And you know how to do that. I've shown you before. I'm starting with 27.37 grams of sodium, and I know that the molar mass of sodium is 22.99 grams. So 1 mole of sodium has a mass of 22.99 grams. So if I multiply, I find out that I have a little more than 1 mole of sodium in my sample. I do the same thing for hydrogen. Hydrogen has, I have 1.2 grams of hydrogen. I know the molar mass of hydrogen is 1.01 grams. So when I multiply through by this, I get a little more than 1 mole of hydrogen. I think I wrote that wrong. 1.88? No. Sorry. I left out a 1 here. 1.18819 moles. Okay, keep going with carbon. Here's the mass of carbon that I have. I multiply by using my conversion factor for the molar mass of carbon to find out how many moles of carbon I have. So remember, I went from grams to moles in each of these cases. And finally, with my sample, 57.14 grams of oxygen, use the conversion factor, get this information from your periodic table, and I find out I have about 3.5 moles of oxygen. So now that I know how many moles I have, I can move on to the third step. In the third step, I'm going to divide the mole amounts by the lowest mole amount. That way the lowest mole amount will become 1. Okay, first thing to do, where is the lowest mole amount? 1.19, 1.18, 1.19, 3.57. Well, I think the lowest mole amount is right here. 1.188119 moles, and it's the hydrogen. So I've set it up with sodium, hydrogen, carbon, oxygen to keep track of where my different elements are. So what do I do? Once I've identified the lowest mole amount, which is right here, I'm going to divide everything by that number. So divide by 1.1881119. When I punch that into my calculator, I'm going to get a 1.00. So that's basically 1. Here I divide by 1.188119. When I punch that in my calculator, I get exactly 1. The next one, divide also by 1, 1, 8, 8, 1, 1, 9, and I get 1 again. And finally, when I divide my 3.57125 by 1.1881119, I get about 3. So what does that tell me? Well, for every 1 hydrogen, there's 1 sodium, 1 carbon, and 3 oxygens. That's what it tells me. So I can now write my empirical formula as sodium, hydrogen, carbon, oxygen. So 1 sodium, 1 hydrogen, 1 carbon, and then 3 oxygens. And that is my empirical formula.